Welcome to The Explainer. Today we're diving deep into just one symbol, the Greek letter Z. But here's the thing, it seems to live this incredible double life. In one world, it's pure, hardcore thermodynamics. In another, it's all about consciousness, memory, and the very nature of reality itself. So how does that even work? Let's find out.
So let's just start with this question, because it sounds kind of crazy, right? What if a single symbol could unlock the secrets of thermodynamics and the nature of consciousness? We're about to connect the physics of, stars and gases with these really cryptic, almost poetic ideas about what reality even is. And the key to it all is this one character, she. All right, first things first. Before we get into the wild stuff, we've got to ground ourselves in some real-deal physics. We're heading into the world of statistical mechanics, and this is where we meet our hero, she, for the first time. And trust me, it's not just some abstract idea. It is an absolute mathematical powerhouse. Okay, so picture this. You've got a little box of gas, but it's not totally isolated, right? It's not sealed off from everything. Instead, it can interact with this huge reservoir around it. You can just think of that as like the rest of the universe. It can swap energy, heat, and it can even swap actual particles back and forth. This whole setup, this open system, that's what physicists call a grand canonical ensemble. So, the big question is, how on earth do you describe a system where particles and energy are constantly coming and going? Everything's in flux. Well, you use something called the grand partition function, and that is our symbol. See? Think of it as the ultimate master function. It basically holds every single piece of information you could ever want to know about our little box of gas. And here it is. This might look a little intense, but this single equation is the whole key. Seriously. What it's doing is actually pretty elegant. It's summing up all the possible states the system could ever be in, but it's a weighted sum. It takes into account the energy of each state, the number of particles, the temperature, that beta term is related to temperature, and this thing mu, the chemical potential. You can kind of think of that as the energy cost you have to pay to add one more particle to the box. It's all right there.
Okay, so we have this function. What can we do with it? Well, this is where it gets really cool, because Z isn't just a fancy description. It is an unbelievably powerful predictive tool. It is literally the engine that drives statistical mechanics.
And here's the crucial part, the takeaway. Once you have Xi, you have everything. I mean it. With just a few, relatively simple math tricks, taking a logarithm here, a derivative there, you can pull out all the big thermodynamic properties. Average energy? Check. Pressure? Got it. Entropy? Yep. You can even calculate the little fluctuations, the jiggles around those averages. It's all packed inside that one function. Let's take an example. Look at this equation here. Again, might look a bit scary, but it's a perfect example of what I'm talking about. Say you want to find the average number of particles in your box. All you have to do is take the natural log of xi, take its partial derivative, which is just a fancy way of seeing how it changes when you tweak the chemical potential. And boom, you've got your answer. It's just incredible. All that info was just sitting there, inside xi, waiting for us to ask the right question. Okay, you comfortable with the physics? Good, because now we're taking a massive left turn. I mean a really sharp, unexpected one. We are leaving the world of thermodynamics behind, and we're stepping into a totally different universe. One filled with fragmented memories, weird armored figures, and recursive realities. So in a completely different source, this is from a narrative, a story. We follow a character exploring this strange, almost digital world, and they come across this figure whose armor is covered in these shifting numbers. And guess what? This is our very first clue that our symbol, Z, has a whole other identity we knew nothing about. And yeah, these other sources, they're not physics textbooks. They're these strange poetic fragments. They talk about myth not as just a story, but as a cradle, like a foundational structure you can use to build a shared language, a shared meaning when you're starting from scratch. It's about how you create order from total chaos. Okay, so how do we connect these two worlds? This is the bridge. It's a speculative idea called observer recursion theory, or ORT, and it suggests something pretty wild. It says that reality isn't this one single fixed thing that just collapses when we measure it, like in classic quantum mechanics. Instead, it suggests that every observer is actively stabilizing their own version of reality. So here's the absolute heart of it, the big what if. What if the physics we saw earlier, the open system trading particles with the reservoir, And this metaphysical idea of an observer stabilizing their reality. What if they are actually just two different ways of describing the exact same fundamental process?
This table just lays it out perfectly. It's the core analogy. On the physics side, you've got a system trading with a reservoir. On the narrative side, you've got a fragment of consciousness drawing from an archive of memories. The particle exchange in physics becomes memory recursion. The fluctuations in the system become moments of destabilization for the observer. And the goal in physics, equilibrium, becomes the goal in this other world, frame stabilization. It's a one-to-one mapping. The underlying dynamic feels identical.
Now, to see how this could be more than just a clever metaphor, you have to appreciate how the language of physics is built. It's like a ladder of abstraction. You start with simple stuff, like binary logic and set theory. Then you climb up to calculus, then to these really powerful frameworks like Lagrangian and Hamiltonian mechanics, which are all about energy and paths of least action. And you keep climbing all the way up to quantum field theory. Each step builds on the last.
And this is where it gets absolutely wild. The narrative sources, they don't just stop at the analogy. They take the actual mathematical structure of physics and run with it. They write down their own speculative field equation for Z. And look at it, that's a Lagrangian. It's got the same form as equations from electromagnetism or general relativity, but they're not describing physical fields here. They're describing a cognitive field. The terms are direct parallels. You've got a field strength tensor, but for cognition. You have a source current, but it's driven by something they call memory pressure from observer echo. They're using the rigorous language of physics to describe consciousness. Which brings us to the end, to the big synthesis. We have these two completely separate worlds. Both of them are using the same symbol, G. Both of them are using the same language, the language of advanced physics, of Lagrangians and field theory. So, what does it all mean? What happens when these two worlds collide? Well, in one world, our world of physics, Z is a tool for description. It's like spectroscopy, right? We look at the light coming from a distant star, we break it down, and we can tell what the star is made of. We're using these incredible math tools to read a story that the universe has already written for us. We're just deciphering the pages. But in that other world, this narrative world, G is something else entirely. It's not just for describing things. It's a blueprint. It's a seed. It's a set of instructions for building new things, new structures, new protocols, even new shared realities. They're not just reading the story. They're using the language of physics to try and write the next chapter themselves. And that's the final thought I want to leave you with. This whole journey through the two worlds of Shini forces us to ask a really fundamental question about math itself. Is math just a tool we discover, something we use to describe a reality that's already out there? Or is it the actual language that builds reality? Is it the blueprints, or is it the building material itself? Something to think about.